Next, we're going to look at monopoly in terms of our models, in terms of demand, cost curves, and so on. Things we've seen before. But what we're going to see is there are some important differences now that the market structure we're looking at is a monopoly. First, let's recall perfect competition. First, let me draw your attention to this marginal cost curve. So this is the marginal cost curve for an individual firm. Remember, in perfect competition, firms are price takers, right? They have no impact on the price. So they look out in the market and say, what's the price today? Well, it turns out it's P. And they say, okay, well, I'll maximize profit by producing the quantity where price equals marginal cost. And you might recall that in perfect competition, for a perfectly competitive firm, price equals marginal revenue. So in fact, at this point right here, price equals marginal revenue, profit for that firm is maximized, and they're going to produce this quantity, small q. But there are many firms just like this firm in this market. And so altogether, they produce big Q. Right? This supply curve is the summation of all the little firms together. And that's what this little jagged line is to represent, is that this quantity is very different. This quantity is tiny compared to the overall market quantity. And so that's where the supply curve comes from. The market supply curve is the individual summation of the individual firm's supply curve. And this is where price is determined in perfect competition, by the intersection of supply and demand, right here. So the price is determined by the intersection of the market supply and the demand curve. But an individual firm just takes this price as given and decides how much to produce. So that's perfect competition from the last chapter. Now over here we have monopoly. There's nothing different about the production technology of a monopolist necessarily. Their marginal cost curve might look just like this. The only difference is the market structure. There are no other rivals in that market. So that's what distinguishes a monopoly from a perfectly competitive firm, not the production technology. Okay, but here's the demand curve. And the monopolist has to decide not only what quantity should I produce, but also what price should I charge. In other words, monopoly is a price maker, not a price taker. And so now we're going to look at that question of how does a monopolist determine what quantity and what price it's going to charge. Okay, we talked about elasticity several chapters back. First, consider the following demand curve. We looked at a demand curve like this in one of the homework assignments. You could plot this if you rearrange this so that you have P equals 10 minus Q. I just rearranged this equation, right? And then you could plot this as follows. For a demand curve, P is on the y-axis, Q is on the x-axis, and so this is what this looks like. And you see this curve here on the left-hand side in panel A. Recall that the elasticity, the price elasticity of demand, differs along a linear demand curve. It's unit elastic. That means price elasticity of demand equals 1 at this precise point. But to the left of it, it's elastic. A 1% increase in price causes quantity demand to fall by a lot. Whereas on the right-hand portion of the curve, 1% increase in price doesn't cause a big change in quantity demand. So that's what we mean by inelastic. But what this figure is useful is showing the relationship between the demand curve and where we're going is deriving the marginal revenue curve. So here we have price and quantity at various levels, right? So here's 10 and 0. That's this point right here. Then we have 9 and 1. That's this point here. 8 and 2, 7 and 3, and so on, right? What is the total revenue associated with these points? Well, if you're charging $10, how many are you selling? 0. So your total revenue is 0. If you're charging $9, you're selling 1. Total revenue is 9. If you're charging $8, you're selling 2. Total revenue is 16, and so on. This curve on the right plots total revenue with respect to quantity. So as you go from 0 to 1, total revenue increases from 0 to 9. What's the marginal revenue of the first unit? 9. marginal revenue equals change in total revenue over change in Q. So if revenue goes from 0 to 9, this is 9. And quantity goes from 0 to 1, this is 1. We have 9 over 1, or 9. What about as we go from 1 to 2? Total revenue goes from 9 to 16. Total revenue goes from 9 to 16. What's the marginal revenue? 7. Thank you. So when we went from 0 to 1, marginal revenue is 9. When we went from 1 to 2, marginal revenue is 7. What's the marginal revenue when we go from 2 to 3? 5. So we see that the marginal revenue is falling. This curve shows the relationship between the demand curve and the marginal revenue curve. It turns out there's a very useful property of straight line demand curves that are going to make this easy for you to remember. It's called the rule of twice as steep. This marginal revenue curve is twice as steep as the demand curve. So it's very easy for you to memorize this. For now, in the next minute, we're going to talk about why it has this shape, but it turns out it's easy to remember. But let's look at why. Well, we already said when we go from producing 0 to 1, marginal revenue is 9. So we plot that here. From 1 to 2, marginal revenue is 7. So that would be here. It's not shown, but this would be the point. When we go from 2 to 3, marginal revenue is 5, and so on. And so if we connect these points, we have this marginal revenue curve. Notice it's negative down here. And why is it negative? Well, if we're producing 5 units, we're selling, it might be easier for me to say it a different way. If we're charging a price of $5, how many are we going to sell? 5. So our total revenue is going to be 25. Let's say we try to increase our sales. So we lower our price to 4. We do sell an additional unit, but our total revenue falls to 24. So the marginal revenue of producing this 6th unit is actually negative, right? So there is one important assumption that lies behind this that I want to make explicit. And that is that the monopolist has to charge the exact same price to everyone. Now, in the next chapter, we're going to look at situations where they can charge different prices to different people. And that's not unrealistic, right? If you go to the movie theaters and show your student ID, you probably get a lower price than what, say, I have to pay, unless I can pass as, with my faculty ID. Same thing with senior citizens. They pay different prices for different things, right? So firms do charge different prices to different people. But here we're assuming they charge the same price to everyone. Imagine it's just like a sticker price. You have to put a price on the item and let people buy it if they want it. If that's the case, then you have to charge the same price to everyone. Under those assumptions, the marginal revenue curve will be twice as steep as the demand curve. In other words, the demand curve intersects the x-axis at a quantity of 10, then the marginal revenue curve intersects the x-axis at a quantity of 5. They begin at the same origin, but the marginal revenue curve is twice as steep. So how does this relate to elasticity? A firm would never produce in the inelastic range. Why? If you're in the inelastic range of the demand curve over here, then if you increase your price from, say, 0 to 5, or 0 to 1, your total revenue increases. Right? In other words, the percentage increase in price leads to a small decrease in quantity demanded, and so your revenue goes up. In other words, if you're in the inelastic range and you increase the price, you don't lose that many customers. And certainly, your point is not to maximize revenue, it's to maximize profit. But if you can raise your revenue by producing less, that's going to increase your profit, right? Because you also are going to lower your cost, right? Because you're producing less. It's possible that maybe for some things the marginal cost of production is 0. If you're selling MP3s, the marginal cost is 0, right? But even then, you would want to increase your price because you're going to be able to charge more to everyone. And so your total revenue will rise. But the main thing to take away from this discussion is that the marginal revenue curve is twice as steep as the demand curve. And the reason for that is, as you lower your price to get more customers, you lower your price not only for the new customers, but for all the other customers who were already buying it. And so that means your marginal revenue is going to be less than the demand curve. This is an important figure also. I mentioned that there's nothing different about a monopolist with respect to its production technology as compared to a firm in a perfectly competitive industry. Therefore, the marginal cost curve looks exactly the same as it did for a perfectly competitive firm. Another similarity between perfectly competitive firms and monopolists is they decide what quantity to produce based on where marginal revenue equals marginal cost, right here. The difference is a monopolist gets to decide what it's going to charge. And so it's going to produce this quantity. How much is it going to charge? Is it going to charge $100 billion for that? No. Because no one's going to pay $100 billion for it, right? So what's the most it can charge? The answer is, in a general sense, whatever people are willing to pay. But luckily, we have a demand curve which tells us what people are willing to pay. And so the most they could charge for this quantity is go up until you hit the demand curve, and then go over PM. You're exactly right. There are 3 steps to determine a monopoly firm's profit maximizing price and quantity. And I can even make this shorter. So I'm going to cross off a few things to make you think about this more simply. So first, I can't do anything about that, but 2, select the output level. 3, determine the price. So really there are 3 steps. Determine what the curves are. Select the output level, and then determine the price after you selected the output level. So now let's go back to those curves and I'll illustrate this. Okay, so in this figure, all the curves are already given to us. So step 1 is done. But we need to next select quantity. Well, just like a perfectly competitive firm, we select the quantity based on where marginal revenue equals marginal cost, and then go down. So, okay, we're going to produce QM. Now we ask ourselves, how much can we charge for this? Not $100 billion, but whatever consumers are willing to pay. So we go up from QM until we hit the demand curve. That happens at point E, and then go over, and then we say, okay, we can charge PM. So that's the illustration of those 3 steps. Do we know how much profit this firm is making? No. We only know the profit maximizing quantity and price. But remember, profit maximizing can also mean loss minimizing, right? So they might be making a loss. What do we need to know to determine the profit? Cost, in particular the average cost. So let's say we knew that the average cost looked like this. Would this firm be profitable? The answer is yes. Why? So let's go through those steps again. And in fact, we can even make a 4th step, determine profit. Okay, so I added a 4th step, determine profit. So first, determine curves. 2, find the optimal quantity. 3, find the optimal P, price. And 4, determine pi, profit. Okay, so step 1, curves are given. 2, find the optimal Q. Well, again, marginal revenue equals marginal cost at point G. This tells us to produce QM. Step 3, find the optimal P. Starting at QM, go up until you hit the demand curve, because we want to charge consumers every last penny that they're willing to pay. And that is PM. Finally, determine profit. Well, we know that we're selling QM at a price of P. But how much is it costing us to produce each of these units? The answer is given by the average total cost curve. So the cost per unit, or the average total cost, is found by starting at quantity and going up until you hit the average total cost curve, and then from there going over. So let's call this C. So C is the cost per unit, right, or the average total cost. Is this firm making a profit? Yes, because it's selling each unit for PM, but each unit is only costing it, on average, C to produce. And so this is the area of profit, this black box. However, if the average total cost was like this, then the firm would not be profitable, right? Because even at the optimum, what's the cost per unit? C prime. So there, this firm is making a loss. Now, there is this heads up here, dispelling myths about the monopoly. The first one is, because there are no rivals, monopoly firms can charge whatever they want. I already said that that's silly, right? You can't charge whatever you want. You can't charge $100 billion. You can only charge what people are willing to pay. So I agree that 1 is a myth. What about 3? Because monopoly firms have the market to themselves, they are guaranteed huge profits. This is also a myth. So monopolists are not guaranteed huge profits. Now, I disagree with number 2. Because actually, and I've said this already a couple times in slightly different words, monopolists will charge whatever the market will bear, right? They actually will charge whatever consumers are willing to pay. So, frankly, I would just cross this off as saying it's incorrect.